Now we'll take a look at calculating quality. The basic concept is pretty simple. If we have a machine or a line and we have product coming in, the in feed, and we have product coming out the out feed, and we have a, I'll show a trash can here. And we have a certain amount of that product going into trash. So if we started 1,000 units and we only saw 900 out the feed, then that means we have 100 in the trash. Now again, this is just the basic concept. So the basic formula that's typical with OEE is good units produced divided by units started. And that's going to equal our quality. So in our case here, good units produced on the out feed is 900. Units started is 1,000. We divide that and we get 90% quality figure. So the idea is if we had 1,000 that we started and we produced 1,000, then we have none that went into trash. And our system is just that much more efficient than if we put 100 into trash and only produced 900 when we could have produced 1,000. And it's a double-edged sword. Those 100 in the trash, we either have to rework or it's waste and we throw it away. Minimizing the amount of units that are bad quality has a direct impact on our efficiency. In the real world, though, that's not always practical. For example, if we have multiple machines, we'll make this a real simple line. We'll say we have a filler, capper, and case packer. So we got units coming in, go to the capper, these all the way down to the case packer, and we have cases coming off. And let's say at any given moment, let's say we have put in 1,000 units and we have 100 units on the line, and then we have our cases coming off. So let's say, we'll just go with the same thing. We've had 90 cases. They're each a 10 pack. So we have 900 cases, or 900 units that we've produced, good units off. And let's say there was no waste, but we have 100 in transit. So it's going to treat these 100 as waste, and that's not the case. So one option to be able to handle this is in Ignition we have this setting called transit time. And what that does is it's going to take a look at the sensor here on the in feed or wherever you might have it, and the out feed sensor and where you might have that, and how long it takes one unit to flow from your in feed sensor to your out feed sensor. And let's say that was 2 minutes, so 120 seconds. So the system will keep it running total of how many items pass by the sensor in the last 120 seconds. And if it was, let's say it's 100. So what it's going to do is it's going to take this 900 units, add that 100 to it, and now we get 1,000, and we'll compare that 1,000 to this 1,000, and you'll get a quality of 100%. So that solves the problem of transit time. Now, you do run into situations where, let's say you have an accumulation table here. And in the case packer goes down, certain circumstances, you start diverting product onto the accumulation table. Now, our transit time isn't going to work because it really didn't take 120 seconds to get down here. It took longer because they routed to the accumulation table, and then eventually maybe they, started offlowing later on, and it ends up being, maybe an hour later. So our transit time really varied in that case. And during that time where we're accumulating, we're going to see our quality drop because this number froze and the in-feed kept increasing. We have a couple other options for how to handle this. One is you can have inspection stations to maybe a vision system, something like that. And if it can detect the rejects and count, we can count. So that was our first option. Two is we can have inspection station counters. And they work the same way as the production counters. And we can count how many have been rejected. We can have multiple inspection stations. We can total those up and use that for our waste calculation. We can also just read a tag in ignition. And that could be, maybe the operator entered that manually. It could come from a foreign, database, external database. Really, any way you can get a value into a tag. So that's another option. Or, the fourth option is don't worry about quality. None. And in some situations that might be appropriate too, and you're not concerned about it. You don't have to use the quality.